And welcome back. So in our previous segment, we talked about what heat was. So heat is going to be given by the letter Q, lowercase q, and it has the units of energy. And we said that heat is what happens when you transfer energy from one system to another, and then it causes that system to have random motions. Now, we want to now talk about what temperature is. So temperature is going to be given by a capital T, and then it has two metric units. So it has the sort of unofficial metric unit of degrees Celsius or centigrade, and then it has the official metric unit of the Kelvin. And so that's what those units are, degrees Celsius and then the Kelvin. So we'll talk more about the units of temperature in just a moment, but let's talk about the definition of what temperature is. So it's going to be a measurement of heat. So the hotter an object is, the more energy an object has, the higher its temperature is going to be. So we don't have devices that measure heat, but we do have devices that measure temperature. And so the higher the temperature is of an object, the more energy it's going to contain. And it's going to be proportional to the average kinetic energy of the molecules. So what do we mean by kinetic energy? So in a previous lesson, we said that kinetic energy is equal to 1/2 mv squared, where m is going to be the mass of an object, v is going to be the speed of the object, and then notice that we need to square it. So this is called kinetic energy. It's energy of motion. And we said in the previous segment that when we heat up an object, it's going to cause the molecules to start to move faster. So let's take a look at these two thermometers. And so the thermometer is going to have some kind of a liquid inside of it. So let's say that this is an alcohol. Now they used to be mercury thermometers, but when you broke a mercury thermometer, the mercury would get out, and then it was fun to play with it because it would make these balls. But it unfortunately is very dangerous. So mercury can be absorbed through the skin, and it can poison you. And so from a historical point of view, they think that Sir Isaac Newton actually went a little bit crazy later on in his life, because he had done experiments with mercury, and he had basically been kind of playing with it, and it was absorbed through his skin. So mercury is pretty bad. Has nothing to do with what we're talking about here, but it's just, again, this class is going to make you popular. So now at a dinner party or something, you can talk about why did Sir Isaac Newton go crazy. It had to do with mercury poisoning. Okay, let's get back to this. So here's our thermometer, and it's going to have some kind of a liquid in it. So normally it's going to be alcohol. So this represents the molecules of alcohol that are inside that thermometer. And now we're going to take this thing, and then we're going to put it inside of a cylinder, and then let's say that there is some water in here that has a certain amount of energy. So let's say it's very cool water, and so the water is also going to be made up of molecules, H2O molecules, and we said that they're going to be moving around randomly. So here's one that's moving in that direction with a certain speed, but here's one that's going faster. So we can illustrate that with a longer arrow. And then here's one that's going slower. And so you see that all of these molecules in here have different speeds. And so the ones that are going slow right now, when they are bumped into by one that's going fast, well, maybe this one will start going fast, and then this one will start going slow. So they're constantly bumping into each other and changing their speeds. Okay, now we know that the energy that's in here can be transferred into here in the form of heat. So as these molecules are moving around, what will happen is that they will bump into the glass. And then when they bump into the glass, they're going to transfer their energy to the molecules of the alcohol. So then these will start to move with a certain speed, a certain average speed, until whatever the average speed of these molecules is, that will be the average speed of these molecules inside of here. Okay, now think about a spring. So if you have a spring and you apply just a little bit of force to it, it's going to stretch. And so it's going to stretch maybe out to here. So you see it got a little bit longer. But if you apply more force to it, then it's going to stretch even more. So what's going to happen is that as these molecules are moving faster and faster, they're going to have a certain amount of energy, and they're going to expand. Just like this thing expanded, these molecules will cause the fluid to expand, and it's going to expand up the thermometer. So this is going to correspond to a certain temperature. So maybe this temperature is 10 degrees Celsius in the metric system. Now let's say that this gets hotter. So if this gets hotter, then that means that these molecules are going to start to move even faster, which means they're going to hit the glass harder, which means they're going to give more energy to these molecules in here, which is going to cause it to expand even more. So now the alcohol might rise up to here, and maybe this is going to be 30 degrees Celsius. So this is the idea of temperature. Temperature is going to be a measurement of the kinetic energy of the molecules of a system. Okay, let's take a break, and when we come back, we will talk about the 3 temperature scales.